Okie dokie. In this problem, they say the average rate of change of a function on this interval is -1. And then they say which of the following graphs could represent f of x. So first thing, average rate of change is just a fancy phrase for the slope. So they're really asking which of these graphs has a slope of -1 between the x values 1 and 3. So on each of these graphs, it might be helpful to visualize a line connecting the points on the function created at x equals 1 and x equals 3. So you want to imagine like a line is passing through these points on every single function. Sorry, I'm focusing very hard as you, well, that already has a line passing through it. Anyway, so we want to find which of these lines has a slope of -1. So hopefully right away, if you're familiar with positive and negative slopes, if not, let me brief you. This line has a positive slope. This line has a negative slope. So we are looking for the line with a slope of -1, right? So we can eliminate these two lines because they have positive slopes. From left to right, they are increasing in value. So these are out of here. So now we're looking at A and B, and we want to know which of these graphs could possibly have a slope of -1, or which of these orange lines here could have a slope of -1. So I think we have to kind of estimate the slopes by calculating them. Let's see. So we might do, I'm going to do two methods here. The first method will be to identify ordered pairs and then find the slope between those ordered pairs. The second will be kind of doing the same thing, except it'll be much faster, where I'll just do like a rise over run situation. So let's give that a try. So for this first one, let's identify the ordered pair at 1 and at 3. So the ordered pair at 1, it looks like it's just below 2, so I'm going to say 1.8. And then the y value, that is. And then at x equals 3, we can see that this is just below -1, so maybe -1.2, okay? So what we're going to do is find the slope between these 2 points by doing y2 minus y1 over x2 minus x1. And what we should get is, I think that's -3. Yeah. That should be -3, so we get -3 over 2, and that is -1.5. So that is not equal to -1. So we can eliminate this one because the slope between those 2 points, or the average rate of change between 1 and 3, is not -1. However, if we look at this graph here, the slope between these 2 points, again, we are going to find not by identifying the ordered pairs, more so just doing like rise over run, like a quick check on the graph, right? So when we start at this point, we rise -2, or we go down 2, and we go over 2. So we go down 2, and we go over 2, rise over run. And this gives us -1. And so the slope between those 2 points, the average rate of change between 1 and 3 on that graph, is -1. So B is our answer. Hope that makes sense. Let's keep it pushing. Let's do 2 more examples. It's a little blacked out here, but you can still see it. The average rate of change we're looking for is a positive 3/2 from 1 to 3. So again, same idea. From 1 to 3, we're looking for a positive 3/2, right? 1 to 3, 1 to 3, 1 to 3. So if we are looking for a positive 3/2, we know for a fact we can eliminate any that have negative slopes, right? So this one, obviously a positive slope, this one positive, and then this one, negative. So we can eliminate any negative options because we are looking for the line with a slope of a positive 3/2. So we're going to do our best to just try the rise over run method. If you're down with that, let's give it a go. So starting with this one here, I'm going to try to make exact points here. So we're rising, so we're going here to here. Okay, so we're rising 1, 2, and just about 3. I'd say we're rising just exactly 3. And then we're running beep, 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 1 and 2. So a rise of 3, whoops, rise of 3, run of 2, 3 over 2. I think that's what we were looking for, wasn't it? Oh, look at that. Okay, yeah, I just randomly started with that one for some reason, but I think that's our answer. So 3 over 2. Let's go ahead and try B and A just to confirm real quick. So this one's barely rising and running here, or barely rising, really. So it might be rising maybe 1, so it goes up maybe 1 and then goes across by 2, so this might be a slope of 1 over 2 between these 2 points here, or an average rate of change. And then if we look at this one, I'm thinking maybe rising, let's see, hold up. We go 1, 2, it might be a rise of 2 and a run of 2, so maybe 2 over 2, which would be equal to 1. So I'm thinking C is our answer based on that rise of a run of 3 halves. Let's do one more, let's see how quick we can do it. This is looking for a slope of negative 3 halves, or an average rate of change of negative 3 halves, also between 1 and 3. So negative, that looks good. Between 1 and 3 here is just barely a positive slope, so we can eliminate that because we're looking for a negative 3 halves. That's negative, and this is also negative. So let's do some investigating here. So we're looking for negative 3 halves. So rise over run, starting here, we're going down 1, and then I'd say we're going down about 2, and then we're running about 2. So negative 2 over 2, that's negative 1, not quite negative 3 halves. I'm going to get rid of that. This one, rise over run, starting at this point, we're going down 1, and then 2, and then 3, and then over, or we're running 1 and 2. So I'd say negative 3 over 2, so that might be it. And then when we look at D, we are rising negative 1, or going down by 1, and then going across by 2, so that might be a slope of negative 1/2. So that is not it. I'm going to go with C, and C is our answer. Hope that makes sense. Average rate of change is the slope, and so the average rate of change between 2 points is the slope between those 2 points. Hope that makes sense. Hope you liked these 2 different methods. I like I prefer the main rise over run method, just the visual kind of looking at the graph situation instead of the little picking the 2 points and finding the slope algebraically, but some people like finding the slope algebraically. So do whatever you prefer. If you have any questions, let me know.